Hello dear students, in this video we will discuss about the chapter Human Eye and the Colorful World. Okay, so let's get started. This chapter covers 5 marks. You can aim for at least 4 marks here because the topics are quite easy and they are repetitive. Okay, so what are the things which will be covered in this chapter? Human eye diagram and some basic details like what is a retina and a lens and all those things. Power of accommodation, very important. This is important. Effects of vision and their correction, again important. Then refraction, which includes twinkling of stars, advanced sunrise, sunlight, scattering of light, color of the sky, sun during sunrise, sunset. All these things will be asked. Okay, so this is a quite a simple chapter which takes very less time for you to understand, and you can aim for 5 marks. What is the first thing you should go through? You should go through the diagram of the eye and understand it. Just practice it. This is quite simple. Let's get into the next topic, that is power of accommodation, which is very repeatedly asked. Accommodation means adjusting. Accommodation means adjusting. Accommodation ಅಂದ್ರೆ ಏನು? adjust ಮಾಡ್ಕೊಳ್ಳೋದು, ಹೊಂದಿಸಿಕೊಳ್ಳೋದು. जो adjust कर लेती हैं उसको accommodation बोलते हैं. Power of accommodation means how much the eye can adjust. eye ಎಷ್ಟು adjust ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ, ಹತ್ರ ಏನಾದರೂ ನೋಡಬೇಕಂದ್ರೆ ಎಷ್ಟು adjust ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ, ದೂರ ನೋಡಬೇಕಂದ್ರೆ ಹೇಗೆ adjust ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. यहाँ पे power of accommodation मतलब जब आप किसी चीज को देखते हैं, अगर करीब में है तो आई कितना एडजस्ट करता है, अगर दूर में है तो कितना एडजस्ट करता है, इसी को पावर ऑफ अकोमोडेशन कहते हैं. द एबिलिटी ऑफ द आई लेंस टू एडजस्ट इट्स फोकल लेंथ is called accommodation. Okay, a normal eye can see objects clearly between 25 centimeter and infinity. That is 25 centimeter is the minimum distance. This might be one question. Minimum distance. What is the minimum distance or the nearest distance I can see? It is 25 centimeter. Please make a note. It is extremely important. This is minimum. And the maximum is infinity. That is unlimited. It might see up to any distance. Infinity is the maximum. Fine. This is important. Power of accommodation. Very important. All right, let's go. Cataract. Sometimes the lens of people at old age becomes milky and cloudy. As you can see in this figure, this lens has become cloudy. If you see, this is normal, but this has become cloudy. This condition is called as cataract. Okay, so crystalline lens of people at old age becomes milky and cloudy. This condition is called cataract. It might cause partial or complete loss of vision. People may not see from this side. Okay, it is possible to restore vision through cataract surgery. This can be one more important question. Cataract. Next is defects of vision and their correction. 3 important defects: myopia, hypermetropia, presbyopia. These 3 are important. Let us try to understand what is the first one. First one is myopia. It means nearsightedness. When you say nearsightedness, it means the objects which are nearby. Objects nearby can be seen. The objects which are far cannot be seen. Okay, the object nearby can be seen, but the objects which are far cannot be seen. See, this is how the eye works. The rays which are coming from far, they come here. Because this is convex lens, they get converged and they fall on the retina. Retina is nothing but the screen where the image will be displayed. Okay, this is retina, where retina is like a screen where the images will be displayed. Okay, but for the people who have myopia, for various reasons, the rays will fall, they converge in advance. It was supposed to come here, but it falls here itself. The image falls here itself and it becomes blurry. Okay, So this is the problem with myopia. The image falls before retina itself, before the screen itself, so they cannot see properly. Correction: how to correct? We have to use concave lens. Use concave lens. So because of concave lens happens, it diverges the rays, it makes the rays wider. Later again our eye again converges this, it comes back to the normal retina. Okay, this is how it is corrected. Myopia important. Hypermetropia, opposite of this. Objects nearby cannot be seen. Objects which are near cannot be seen. Objects which are far can be seen. Now what happens with this is, when the object falls, the image forms beyond retina. रेटिना बिटबिट ತುಂಬಾ दूर होगुत्ते, रेटिना से दूर, स्क्रीन से दूर इमेज फॉर्म हो जाएगा. हाउ टू करेक्ट? ऑपोजिट ऑफ दैट, जस्ट यूज ए कॉन्वेक्स लेंथ, तो और भी जल्दी करेक्शन हो जाएगा और जल्दी यहाँ पे आ सकता है, इನ್ನ ಬೇಗ ಕರೆಕ್ಷನ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಏನು ಯೂಸ್ ಮಾಡಬೇಕು? ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕು, ಹೈಪರ್ಮೆಟ್ರೋಪಿ. ಓಕೆ, next one more is presbyopia. Presbyopia due to age factor it happens. How to correct? Use bifocal lens. use bifocal lens. ಎರಡು ಲೆನ್ಸ್ ಇರಬೇಕು ಇಲ್ಲಿ, ಕಾನ್ಕೇವ್ ಮತ್ತೆ ಕಾನ್ವೆಕ್ಸ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ presbyopia ಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಓಕೆ, next important topic is refraction. Refraction, you know that very well. When we see the pencil in the water, it does not look in the same line, it looks slightly here in the different line, correct? This is called as refraction. ನಾವು ಒಂದು ಪೆನ್ಸಿಲ್ ನ ನೀರಲ್ಲಿ ಇಟ್ರೆ ಪೆನ್ಸಿಲ್ ನೀರಿನ ಆಚೆ ಇರೋದು ಒಂಥರ ಕಾಣಿಸುತ್ತೆ, ಒಳಗಡೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಸ್ಟ್ರೈಟ್ ಕಾಣಲ್ಲ, ಸ್ವಲ್ಪ ಬೆಂಡ್ ಕಾಣುತ್ತೆ. जब आप एक पेंसिल रखते हैं पानी में, तो पानी के बाहर का हिस्सा एक लाइन में लगता है और पानी के अंदर का हिस्सा सेम लाइन में नहीं रहता है, थोड़ा बेंड होकर रहता है. इस प्रॉपर्टी को रिफ्रैक्शन कहते हैं. The same property works here. Okay, rainbow is also created by refraction, because rainbow, this sunlight actually consists of these rays. Okay, these 7 lights it consists. So when it falls on a raindrop, it gets refracted into the medium, and again it gets refracted into the medium internally within the raindrop. So what happens ultimately when it comes out? It gets refracted and you can see 7 colors. This is called as rainbow. So rainbow is caused by dispersion of sunlight by tiny water droplets. Because of the water droplets present in the atmosphere it happens. Okay, you should always remember, rainbow is always formed in a direction opposite to that of the sun. It will not be in the same direction, it is always in the opposite direction to that of the sun. Okay, refraction. Twinkling of stars, again because of refraction. In the atmosphere there is a refraction of starlights. For example, star is here, the ray is supposed to come here, but because of the atmosphere it bends here. As you can see, light is coming from the star straight, but when it enters atmosphere it might bend like this, bend like this, different ways it keeps on bending. Because of that we see the twinkling of stars. Okay, because of atmospheric refraction of starlight. Advanced sunrise and delayed sunset, again same thing, because of atmospheric refraction. For example, this is earth, this is where one observer stands. Okay, this is horizon, which means I have to see the sunrise when sun comes here. But what happens, sun is still here, our sun is still here, but when it shows the sunlight it gets refracted, and the person standing here feels that sun has already reached here. It gets refracted. Sun rays refraction ಆಗಿ ಏನು ಅನ್ಸುತ್ತೆ, ಸನ್ ಇನ್ನ ಕೆಳಗಡೆ ಇದಾನೆ, ಹಾರೈಸನ್ ಈ ಲೈನ್ ಇದೆಯಲ್ಲ, ಹಾರೈಸನ್ ಇಲ್ಲದ್ರೆ ಕೆಳಗಡೆ ಇದಾನೆ, बट सन मेलगड़े इदाने अनसुत्ते. सनराइज में अभी एक्चुअली सनराइज हुआ ही नहीं है, हॉराइजन पे सन आया ही नहीं है, बट ये रेस क्या होते हैं यहाँ पे अर्थ के एटमॉस्फेयर की वजह से, जो एटमॉस्फेयर रहता है रिफ्रैक्शन होके ये इंसान को ऐसा लगता है कि ये सन रेस यहाँ पे है और सन यहाँ पे है, ऐसा लगता है। इसीलिए सनराइज हमेशा एडवांस रहता है, 10 मिनट या कुछ मिनट पहले रहता है सनराइज। इसी का ऑपोजिट काम होता है सनसेट। सनसेट में क्या होता है, बिकॉज ऑफ एटमॉस्फेरिक रिफ्रैक्शन सनसेट लेट होता है। ऑलरेडी सनसेट हो चुका है, बट बिकॉज ऑफ रिफ्रैक्शन लगता है कि सन अभी यहीं पे है, सनसेट हुआ ही नहीं है। ओके, दिस इज बिकॉज ऑफ एटमॉस्फेरिक रिफ्रैक्शन। ठीक है, इंपॉर्टेंट क्वेश्चन है। नेक्स्ट क्वेश्चन आता है स्कैटरिंग ऑफ लाइट के बारे में। व्हाई इज द स्काई ब्लू? स्कैटरिंग ऑफ लाइट ಅಲ್ಲಿ क्वेश्चन ಬರುತ್ತೆ, ಸ್ಕೈ ಬ್ಲೂ ಏನಕ್ಕೆ? Scattering of light happens because of the molecules which are present in atmosphere. They scatter the light rays. Molecules are there in atmosphere, they scatter the light rays. Okay, in the sky the molecules are shorter wavelengths, they scatter, they get more easily. Molecules of shorter wavelengths, so VIB G by O R, this is longer wavelength. These are blue or shorter wavelength, blue violet. Okay, these are shorter wavelength, they get scattered very easily. So in the entire sky they get scattered, the blue rays easily they get scattered. That's why we'll see the sky as blue. But what happens during sunset, the sun is far, because of the atmosphere more scattering will be there. More scattering means the longer sun rays, that is orange and red, will be seen during sunset or sunrise. Okay, usually during sunsets. At afternoon, sun is right above our head, there will be very less scattering, very less scattering, so sky will be completely blue. But when you observe the sun, it looks white. Sun will look white because of less scattering. Sun will look red because of more scattering. This question might be asked. Okay, let us look at the model question paper. Types of the lens to correct nearsightedness, that is myopia. How do you correct? Using concave lens. Yeah. Color of the sky from the surface of the moon. From the surface of the moon, what happens? Moon does not have atmosphere. Moon does not have any atmosphere, so no scattering, no scattering of light. That's why it looks black. The color of the sky from the moon atmosphere, it looks black because moon does not have any atmosphere, so it looks black. Twinkling of stars we discussed already, refraction, and rainbow also internal refraction we discussed, right, due to droplets. Accommodation we have seen already, adjustment of the lens, power of accommodation appears as white, we just now discussed this also. Okay, I hope the video was useful to you. Please go through this chapter, go through the video, it's quite simple way I have explained. And please like, share and subscribe my channel so that it will give benefit to you, and share this with others, it might benefit others as well. Thank you so much.